Okay, so now we've got to open up, oops, sorry. OneDrive. It should be here.
I'll do it.
Oh, what in the world?
I just don't get it.
Did you add another?
Okay, so make sure that you pay close attention because we're about to get to some of the most important problems in college algebra. In fact, the ones we're about to get to is what computers in the world spend most of their time doing. Have you ever thought about that? We're not quite there yet, though. So the next question I think we have to do is number 7. Is that right? Number 7. So everybody pay close attention and let's do question 7 together. 4x plus y less than or equal to 8. 2x minus y less than or equal to -1. X greater than or equal to -5. Y less than or equal to 7. So let's draw that inequality. Ready? So let's start with the first one. So let me see if I can find this yardstick. And let's actually start with the bottom up, I guess. So the changes to an equal sign and describes the line y equals 7. And tell me if I should do a solid line or a dashed line for that. So let's do y equals 7. Let's draw a solid line for that. I'm going to do the lines in blue so that it will be easy for you. 3, 4, 5, 6, 7. I'm going to draw a y-intercept of 7 and a solid line, right? Presto. And that's S7, right? Now let's work our way up to the next one. Let's draw that. So change this to an equal sign and draw the line x equals -5. Should I draw that one to be a solid line or a horizontal line? I mean, sorry, a solid line or a dashed line? Solid. So go to x equals -5. Draw a solid line that way. I just realized I forgot something critical. There we go. What did I forget? Forgot the arrows. So for the first line, should the arrows go vertically downwards or upwards? Downwards, because the y is on the lower side of that line. So on the first one, I need to draw my arrows going downwards, like that. And then on the second line, which way do my arrows go on the second line? This way. The x is on the big side, which is towards the right. So my arrows need to be going towards the right. There we go. Perfect. Then let's go to the next one. So changes to an equal sign. And remember how I taught you to do it. To find the x-intercept, you can cover up y. Make y be 0. You're not really covering it up, you're making it be 0. So if I cover up the y, well, it's going to be a fraction. So that's not a good idea. So let's do it the hard way. There we go. By the way, does anybody know about anybody who does things the easy way and the hard way on the internet? Have you ever seen the brother and sister that do science experiments together on the internet? And he always said, and he always says, "Do you want the easy way or the hard way?" Or she always says, "Do you want the easy way or the hard way?" So those changes to an equation. Let's get y by itself. What can I do to get y by itself? -2x, correct? So if I put the -2x on the other side, you'd have that. So I kind of skipped a step, but hopefully you'll forgive me for that. So I just subtracted 2x from both sides. That moved it to the other side. Now what's the next step? Divide by -1. So since you're all so smart, I'm going to also skip one step and just get the answer. So if I divide by -1, I would get that. Do you agree? And then, thank you very much. Did everybody get signed in on the sign-in sheet? On the back row? Everybody? How about on the second row? How about on the third row? Uh-oh. You're welcome. Thank you. All right. Now, so this means the y-intercept is 1. So let's draw the y-intercept of 1. Boom. Is it, by the way, is this going to be a solid line or a dashed line? Solid, because it had an equal sign in it. So y-intercept's going to be 1, and slope is 2 over 1, which means we go up 2 and then over 1. So that's going to be the second point, up 2 and over 1 to the right. Then I'm going to draw that line. Boom. Boom. Like that. Okay, and then should I shade below or above that line? Just sort of a trick question. Looks like I should shade below it, because that the y is on the left hand side, but guess what? The negative y means it's not really there. It actually means if you have negative something on one side, it actually means that you actually have positive of it on the other side. But that y actually exists on the right side, not the left side. So y is on the bigger side, so we should shade up. We should shade upward. So we should shade upwards from that line. And then last but not least, let's do the top one. This one will work the easy way. What's the easy way of drawing a line? That's just making the variables be 0. So if I make the y variable be 0, then what's the x-intercept going to equal? So to ask yourself, 4 times what? Replace the x with the word what? 4 times what equals 8? 4 times 2 equals 8, right? So the x-intercept is 2. This x-intercept is 2 afraid of math. No, not that kind of 2. But now cover up the x, make that be 0. And then you get y equals 8. So the y-intercept is equal to 8. So go to the y-axis, put 8, and connect the line. By the way, should this be a solid line or a dashed line? Solid, and should I shade left or right of it? X is on the little side of it, so I should shade left. And also y is on the little side, so I should shade down. So left and downwards is pointed to the lower left, like that. So what area of this graph, by the way, how many areas are there? There's 1 area, 2 areas, 3 areas, 4 areas, 5, 6, 7, 8, 9, 10, 11, 12. There's like a lot of areas. What's the area that all the arrows are pointed towards? Yeah. Smart. The one that looks like Nevada. So, by the way, has anybody ever been in like Las Vegas at the airport, like flying to California or something? And I have never actually been in the city of Las Vegas, but I'm told that it just ends like at the desert. It just like suddenly just ends. Is that right? There's like a city, and then boom, there's just desert. So there's the solution. Does that look right here? Okay, perfect. Okay, well, by the way, is that solution an infinite solution, or is there a boundary to the whole solution? There's a boundary all the way around. So at least with this one, you can't get stuck drawing it forever for the rest of your life. Now we're gonna get to an interesting question though. I'm gonna show this to you on the computer, so it'll be easier. You ready for that? So let me close that thing, and I'm gonna open up the magical computer and go to question number 8 on the homework. Wow, there we are. By the way, has the cafeteria been good this semester? I've never had time to try it out yet, except for once at this faculty meeting before the semester started. Oh, that's cool. What's the best day of the week to go? Do they have like leftovers on Friday or on Monday?
Leftovers?
Yeah,
Weekends.
weekends. Okay, good. So if I go there on like a Monday, it's better. Except to have office hours during Monday. In fact, my only office hour is today that I don't have time for lunch is today, but I already told somebody I'd help them with their math. So won't be able to have lunch today either. Let's see. But maybe next Thursday, if I skip chapel, I can go.
$7.
Although actually, I think we have a meeting. My department had scheduled a meeting to like get ready for the schedule deadline. So I don't think I'll be able to go then either. What about breakfast? Oops. By the way, I'm so used to looking at your grades and checking up to see how you're doing. I automatically clicked on the wrong button by mistake. Assignments is what I meant to say. Let's look at question number 8. There we go. Okay, so this is the question. It's really small though. Let me see if I can make it bigger. That's not much bigger. Whoa. Uh-oh. Oh, there we go. Let me click that button. Okay, is that better? I still don't know why I can't make it bigger. This is such a silly website. Wait, I have an idea. Look at this. Copy image. Let me open up Paint. And then let me see if I can paste that image into Paint. Wait, this did not work. Oh, come on. Oh, how about this? Save image as. That did not work either. It's not letting me save it. What in the world? I'm just trying to make this bigger so you can see it better. Clipping tool. Sorry. Didn't think about that. Snipping tool. There we go. Now, copy that. And there we go. And then I'm gonna do big screen and then zoom in. How's that? Is that more visible now? Perfect. Okay, so making things visible is like one of the essential parts of learning. Whoops, sorry, my fault. Okay, so now I'm gonna go to this window and share this. By the way, guess what's the nicest thing about Zoom is sharing things. So I'm trying to, whoops, now it's covered up the top of it. Hold on, there we go. Can everybody see that now? So this question says that we're supposed to find the value of something. Let me write that value down real quick. It says to find the value of z equals 3x plus 4y. So let me write that down. So it says z equals 3x plus, does anybody notice how it gets blurry after I let go? Why does it get blurry after I let go? Plus 4y. So it gets blurry after I let go. Okay, so z equals 3x plus 4y. We're supposed to find the value of that at each of the corner points. And by the way, let me teach you a little bit of vocabulary. These corner points are called vertices, and each corner point itself by itself is called vertex. So the singular vertices is vertex. So we have to find the value of that equation at each corner point. Right now, it just seems random. Why are we doing this? Well, it'll make more sense later on. So if I plug in the value of 3 for x, you'll get 3 times x, which is 3, plus 4 times y, which is 9. It's kind of hard to write with the computer mouse. Not gonna lie, it's kind of hard. So z equals that. What's 3 times 3? 9, and what's, yeah, I'm getting from A, yep. So what's 3 times 3? 9. What's 4 times 9? 36. So we get 9 plus 36. Wow, it's a struggle. I feel like I'm in like 5 years old, like when I'm learning to write. Struggle. Yeah.
Why can't you put it on the iPad?
Well, I could, except then I wouldn't be able to have the graph like visible.
Log into your iPad now and share your screens sometimes.
I could.
And then use your pencil to draw.
That might, well, the thing is, I'm not sure if I can draw on top of an application window. But
36.
I might be able to though. The 36?
Yeah, 4 times.
4 times 9. Yep,
That's a 4. I thought that was
that's all right. Yeah, it looks like a wild 4. There we go. How's that? 9 plus 36, that's 45. So I get 45. Perfect. So our football team maybe could score 45 points to 0. Maybe. Okay, so we got 45. And then the thing is though, here's the crazy deal though. All of the lines around that shape represent in an abstract way the decisions that you could make. And the best decisions in math theory they call this a convex optimization problem. Did you ever hear that before? And they have like huge books and everything about this. And this is what computers spend most of their time doing. Have you ever thought about how, when you dial a phone number, how does the phone number go from like right here? How does it find its way to like a cell tower? Because there's like thousands of cell towers in Wichita. How does it find its way to like one of them specifically? And then like the next one so that it can somehow reach, so the signal can reach whoever you're calling. Because there's probably trillions times trillions of different options it could take. So there's computers like sitting there in server rooms that calculate the fastest way so it doesn't interfere with other people's phone calls and it gets to the right place and it gets there as fast as possible. They call those problems convex optimization problems. And this shape right here is called a convex shape because there's no like dips that go down inside of it, like there's no like bites, like Pac-Man bites out of the middle, out of the edges of the surface. So that's why it's called convex. And the green area represents the feasible solutions. The boundaries represent the like extreme possible limits of it. And the corners represent either the worst or the best solutions. So like the very worst possible place to send your phone call to is going to be one of those corners. The very best place to send it to is going to be one of the corners as well. The only problem is that you don't know which. That's why computers are sitting there calculating all the corners of these things trillions of times every second all around the world. One of my algebra books said that they estimate that about 53% of computer time, out of all computers in the world, about 53% of them are being used at any given point to solve problems like this. Because that's like that's how your calls get called. That's how the UPS decides which route the trucks should take as they deliver your packages and things like that. So what we're going to do next is we're going to find the value of it at the other corners as well. So let me go ahead and I'll assign this to you. So who wants to volunteer to find the value of Z at the corner B? So
And we will just do the same thing,
yep,
like, yeah.
take the number 7 and do 3 times X. So do 3 times 7 plus 4 times 5. So tell me what the value is that you get, and then I'll write that down. 41 total?
Yeah.
So for that value of Z is equal to 41 at that corner. Okay, perfect. Now, who's ready to volunteer to find this? So somebody volunteered to do it at part C.
It's 36.
36,
The number.
36. And then I can't see it very well, but somebody find the value of at a point D. 11. Genius. Wow. Such overachievers. Must have already done it already. Okay, so there's 4 answers. Now, depending on what your goal is, each of those answers is either the best or the worst. If you want to make more money, for example, and Z represents money, then you want the most. So which of those is the most money? 45, right? A would be the best. So that's the maximum. The maximum value of this problem is 45. Except, what if you want to save money though? Well, then if you want to save money, the best answer is the smallest one. So 45 is the max. Which one's the smallest one? The 11. So the minimum is 11. So remember I said that the best and worst or the highest and lowest solutions will always be at the corner points. You could take any other point within this graph, like you could take this point right there, which would be, but that's 1, so 2, 3, 4, 5. And then this would be 2, 3, 4. You could take the point 5, 4 and plug it into the formula. You get another answer, but it wouldn't be the highest or the lowest. It would be somewhere in between. So the cool thing is you can actually constrain, you know that the values all the green parts, like all the other pathways the UPS truck could take, would either be something more than the minimum or something less than the maximum. So there's no point in driving your UPS truck down these streets right here, because the best way for it to go would either be that point or that point, depending on whether you want to get the most or whether you want to get the least. So you have to analyze those corners to figure out the answer. So let me stop sharing on that one. And let me actually try your idea of sharing it on my screen. I'm gonna see if that will work. You ready? It could. Let me try it. Except what I'm gonna do is I'm gonna take a screenshot
Yeah, I was gonna say, or you can screenshot it and like.
and then I'll share the screenshot on my
Yeah.
page. Okay, so ready? So it's gonna be a little hard though. iPad. Okay, so I'm just gonna show you the question. Now, unfortunately, I already have the answers typed in, so just ignore the answers.
I've been on the river yet.
Okay, so this is question example number 10. Ready? So can you see that well enough?
No. It needs to be a little bit bigger.
A little bit bigger. Let me zoom in. Yeah, there we go. How's that?
Oh, that's even better.
So the objective function, it represents what they're trying to calculate, like the cost of your delivery or the time of the delivery, for example. So if it represents cost of the delivery, you want the cost to be the smallest. If it represents time of delivery, you want that to be the smallest. But if what's something that would be the most, though, that you want the most for? Profit, yeah. If it represents profit of the delivery, you'd want that the most. By the way, I tried to sell something on eBay recently with my sister's help, and the value of the product when you buy it new was like $999, and it only sold for like $340, and I had to pay $51 of selling fees. Isn't that crazy? So I got like $290. Plus, I had to buy a shipping label, so it was like $18 for that. So eBay wasn't a very good deal to buy with. Next time I'm gonna try Craigslist maybe.
What were you selling?
I was selling a camera lens actually. So there's the objective function, there's the constraints. So the first step is we have to draw the graph. We have to draw these inequalities. So let's draw those inequalities. And then we'll know what to do. So, ready? So I guess I'll have to share another screen real quick. Whiteboards. Wait, can I share a new one at the same time or not? No, I guess I'll have to stop that temporarily. So new whiteboard. I'll draw this one. Oops, it's in the wrong mode. Okay, the trouble is with this whiteboard is it slides. While I'm writing, sometimes it'll just like slide to the side and it'll make, like imagine if you're drawing on the chalkboard and it just starts to move all of a sudden. Let me try again. There we go. Okay, this is the right one. Okay. I have a copy of that picture that I just put on your screen. And I'm gonna work with that. So the equation said x is greater than or equal to 0. X is greater than or equal to 0. I'm going to draw that. So here's 0. Here's x. That's going to be a solid line going vertically, right? It's going to be going towards the right. Second equation was y is greater than or equal to 0, like that. Second equation was y is greater than or equal to 0, and that's going to be a horizontal line going like this. And it's going to be above that. There we go. Third one is 2x plus 3y less than or equal to 18. That's going to be, okay, can somebody help me with this? So imagine you're covering up the y. So pretend like the y is gone. By the way, I got an idea. Watch this. Settings. Watch this. I can make the cursor be really big. How's that?
Oh, my lord.
Now, next time somebody uses the computer, they're gonna wonder what's wrong. So if we cover up the y, make the y gone, be 0, then what's the x-intercept? Yep, so if 2x equals 18, x would be 9. So I'm gonna draw 9 on the x-axis. And then if I cover up the x, and I say that's 0, 3 times what equals 18? 6. So the y value is 6. So I get 9 and 6. That's going to be a line. Boom. And then the last equation was x plus y is greater than or equal to 3. X plus y is greater than or equal to 3. So if I cover up the x in that one, you just get y equals 3. If I cover up the y in that one, you get x equals 3. So that one is just a simple line like that. Now, unfortunately, those lines don't really cross each other. But in reality, I think they probably do, though. Oops, hold on. Let me just check one thing. Okay, actually, they don't cross each other. At least they cross each other somewhere way out yonder. So these lines have a slightly different slope, so they're kind of coming together like this. So eventually, up to the left, they're eventually going to cross each other. But that doesn't matter, though, right now, because we're only going to look at the part that is between them. So should I shade below or above the top line? So the top line, should I shade below that or above that? Below, because that top line says less than or equal to, so I should shade below that. To shade below or above the bottom line? Above, because it says greater than on that one. So that means the area that I need to find is this little box right there. And that little box is called the feasible region. Let me go to a different color again. Feasible region. So that's basically the places that UPS truck can drive that would actually take you to the destinations that you need to go. So that's did I write feasible religion? Sorry about that. Okay, one of the most hilarious things I've ever heard was one day this preacher was preaching a sermon, and instead of saying immortal life, or instead of saying to be immortal, what do you think he said? To be immoral instead. So it was like a super awkward moment as well. So that was hilarious. I think the congregation started laughing almost. So there's a feasible region, and what are the corner points of the feasible region? Well, that point right there is at 9, so the y value is at 0. That point is at 3, so the y value is 0 as well. This point over here is at y equals 3, so the x value is 0. This point is at 6, so the x value is 0. So the first point, those are the 4 points. So once again, we have 4 different points, correct? So now our problem, I want to actually leave this on the page so I don't have to erase it. The problem that we were doing was z equals 7x plus y. So that's z. Now let's find the value of the equation z at each of those corners. I'm going to circle the corners in pink and hot pink so you can see them better. There we go. Perfect. So tell me the value of z at the top middle corner, the very top corner, 0, 6. So what is z of 0, 6? By the way, if you want to, you could even put the 0, 6 next to the z like that. So what's the z value of 0, 6 plugged into it? What's 7 times 0 plus 6? Well, 7 times 0 is 70, right? And so that'd be 70 plus 6 is 76. Is that correct? Just kidding. It's not 70, even though it looks like 70. It's really 0 plus 6. 0 plus 6 is 6. And then what's the z value of the left upper corner? What's the value of the left upper corner? So the 0, 3. What's the value of 0, 3 plugged in? It'd be 7 times 0 plus 3. What's that? That'd be 3. What's the value of it at the right middle corner? So what's the value of it at 9, 0? What's the value of 7 times 9 plus 0? What's the value of that? That would be what? By the way, has anybody ever heard of this trick of 9? I did not even know this when I was in college. But if you multiply by 9, like 7 times 9, all you have to do is hold up 10 fingers and put down the 7th finger. 1, 2, 3, 4, 5, 6, 7. And the answer is on your fingers. So see, this makes 6 fingers on this side plus 3. So the answer is 63. Has anybody heard of that trick before? So few of you have. It's a pretty cool trick. And then, so no wonder now I realize why some kids never had to have trouble when they were multiplying by 9. Because I never learned that trick. And then the last but not least, the middle bottom number is 30 to plug in. So it'd be 7 times 3 plus 0, 21. So those values are 6, 3, 63, and 21. Okay, then now let's try to find the maximum. And this problem wants you to find the maximum value. What's the maximum value of the entire problem? So like the most profit. 63, right? So imagine you're investing money in the stock market every day, and you had a computer figure out which stock to buy. If you bought these 3 stocks, you'd only make $6 or $21 or $3. But if you bought that one, you'd make $63. Wouldn't it be smart to buy that one then? So that's the maximum point is 63. Now, it says find the values of X and Y when the maximum happens. So find the values of X and Y when the maximum happens. So we have to backtrack. The maximum happened at those numbers right there, 9 and 0. Like that. By the way, if you're curious, it happened at X equals 9, Y equals 0. If you're curious, you could also try any of the other points. Any point that would fall within that yellow region is also a feasible point. Like you could try this one right there, like 3, 1, for example. Wait, that sounds like that might work. Well, what's 7 times 3 is 21 plus 1 is 22. Okay, but it still wouldn't be bigger than that. You can try them all. None of them would ever be bigger than the max. That's why it's so cool, because by plotting the region and finding the corners, you can actually make sure that you're finding both the best and the worst solution without trying everything in between. So have you ever wondered like what decisions to make in life? Wouldn't it be cool if you could mathematically diagram everything and just figure out the corner points? And then you would know which decisions would be the best or the worst. Except then you'd have to try them all though, and then you might try the worst one first, maybe. So sadly, this can't tell you without trying them which one's actually the best. You have to try them all, plug them in to find out which one's the best. All right, well, so the next problem, number 11, works exactly the same way. So I want us to try to do a problem that's actually really cool together. Ready? So who wants to be helpful? Does everybody want to be helpful? Who wants to be helpful in life? Not today, but just like in life. So one way, good. Yeah. So one way to be helpful is to be a tutor.
Oh.
So in question 12, in question,
Me.
so in question 12, it says that you earn $10 an hour for tutoring. So imagine that you earned $10 an hour for tutoring. I don't know if that's actually what people make. So you earn $10 an hour for tutoring, and you earn $5 an hour for being a teacher's aide. Well, that's a bad deal.
Yeah.
So you earn $5 an hour for being a teacher's aide. I'll just say aide for short. So you earn $10 an hour for tutoring, and you earn only $5 an hour for being a teacher's aide. Oh, actually, aide is spelled with an E at the end. Sorry, my fault. Teacher's aide, like that. It says write an objective function that describes your earnings. So your earnings would be called Z. How much money would you earn if X represents the hours you work for tutoring? So X is how many hours you work for tutoring. And if Y represents how many hours you work as a teacher's aide, what's the total amount that you earn? It'd be 10X plus 5Y, right? So this is an example of this problem. However, though, the student's life has 3 constraints on it. In order to have enough time for studying their college classes, the student cannot work for more than 23 hours per week. So the number of hours the student works for tutoring plus the number of hours the student works for being a teacher's aide cannot be more than 23 hours. So that's the first mathematical constraint. The tutoring center requires that you cannot be a tutor unless you have at least 4 hours of availability of tutoring per week. So X, the number of tutoring hours, has to be at least 4 hours or more.
Did you pick 23 or is that in the question?
That's in the question. So yeah. It's in part 1. This is question 12.
Yeah, I'm on 12 or one.
Yeah, in 12 part 1, it says to have enough time for studies, the student can work no more than like 23 hours per week. So it might not say 23, it might say like 25 hours per week. The tutoring center requires each tutor has at least 4 hours a week of tutoring. And it says the tutoring center says you cannot spend more than 8 hours a week tutoring either. Like that. All right, perfect. So you can't have more than 8 hours of tutoring, so you have to be less than or equal to 8. Now we have to graph the system. So let's graph the system of inequalities. Presto. Graph the system. I'm gonna go switch to black. Black is more easy to see. So the first equation right here, x plus y is less than or equal to 23. That have an x-intercept and a y-intercept, both of what? 23, right? So that'd be and it would be a solid or hollow line. I mean dashed, solid or dashed. It'd be a solid. Presto. And then the next line would be a vertical line, 1, 2, 3, 4. A vertical line at 4. Presto. And then the next line would be a vertical line at 8. So here's 8. Presto. Boom. All right, then I'm going to shade underneath the first line. So below, I'm going to go back to pink now, actually, because it'll look different. So underneath the first line, and it's bigger than the second line, so it's to the right of the second line, and it's left of the second line. Now there actually is no, they don't mention this though, but you can't work for negative hours though. So like you can't work for negative hours as a teacher so that you can work for more hours as a tutor, for example. So you actually just assume that you can't go below 0 hours. So I'm going to shade the feasible region. So the yellow region is the part in that little box. How many corners are there of that little box? There's 4 of them. So I'm going to help you find the easy ones and you can help find the hard one. No, just kidding. Well, let's start with the easy ones. So what's the first corner down there of that box? Let me go to purple so you can see it better. What's the coordinates of that first corner that I put a purple dot at? It's at x equals 8, right? And what's the y value when you're down along that line? 0. So the first corner is 8, 0. This second easy corner is 4, 0, right? 4, 0. Third one is not easy though. It's up there. So I know that x equals 4 because it's still on the straight line. However, though, how do you find the y? Well, the y is on the black line. You have to take the x value of 4, plug it into this y, the x value of this. So you take the equation that says x equals 4 plus y. So take this equation right here and say x plus y equals 23. Change x to be 4 and say 4 plus y equals 23. Subtract 4 from both sides. Tell me the final step if I subtract 4 from both sides. What does 23 take away 4? 19, you're right. So you have 4, 19. That's the fourth corner. I mean, that's the third corner. And then how about that corner? What are the coordinates of this last final purple point? Like that. By the way, have you ever heard of this strange song called Flying Purple People Eater? Ever heard that? One-eyed, one-horned, flying purple people eater. Okay, so there's the last purple dot. And how do I find the coordinates of that last purple dot? Well, at that last purple dot, remember x equals 8. So go up to this equation right here and plug in 8 for x. You get 8 plus y equals 23. Subtract 8 from both sides. What's 23 minus 8? It's 15. So if Michael Jordan didn't eat, it'd be 23 minus 8. He'd only be number 15. So y equals 15. So it's x equals 8, y equals 15. That's the fourth point. So does everybody understand how to find the 4 points at the corners? Okay, perfect. Now we're going to try to figure out the best decision for this tutor to make them either the least money or the most money. So those 4 points, all of them are the possibilities that could give the most or the least. Now, no individual point is guaranteed to be the most or the least. In fact, sometimes the points are neither one. But it is guaranteed that if you try all the corner points, that at least one of them is the most, and at least one of them will be the least. So let's try them out. Somebody take the number 80, plug it into the equation of how much the tutor makes. So plug it into the equation $10 an hour plus $5 an hour. So take 10 times 8 plus 5 times 0. And what do you get? What is 10 times 8 plus 5 times 0? What is 10 times 8 plus 5 times 0? 80. Good job. And what is 10 times 4? Because we're doing $10 an hour, 10x plus 5y. What is 10 times 4 plus 5 times 0? What's 10 times 4 plus 5 times 0? It's 40. All right, then what about 419? That'd be 10 times 4 plus 5 times 19. What does that equal? What's 10 times 4 plus 5 times 19? That's too complicated. 135? All right, perfect. Good job. And then what about 815? What is 10 times 8 plus 5 times 15? 155? Okay, so which of those decisions would be the smartest decision if you wanted to make the most earnings per week as a student? It'd be the one that came out to the most money per month, right? Per week. So you should do that. So based on that, work your way backwards and tell me how many hours you should work tutoring. How many hours should you work tutoring in order to get $155 per week? Tutoring for how many hours per week? 8, yes, because X represented tutoring hours. So you should tutor for 8 because 8 was X. And then how many times should you spend as a teacher's aide per week? Well, that point had what Y value in it? 15. So you should be a teacher's aide for 15 hours per week. Then you make the most money. So you could do other options that would make a little bit less money, but that would be the money and that would be the most. Does that make sense? So every single scenario, and no, of course, this doesn't apply to everything, but as long as the information is a simple linear line, you can plot that on a graph, like the money that you need to make and the hours you have available like that, like for lunch and supper and everything else. You maybe put that on a graph, and then you can decide how to make the most amount of money possible. So once you know how to do that, you pretty much know how to do all the rest of the problems, except you might have to click on the button that says view an example. It'll show you an example of how to solve some of the questions as well if you have trouble. So work your hardest and best on learning all these questions. And if you have questions, you can get them at office hours on Monday or whenever you want to. Keep on being great and excellent like that. And by the way, let me just make sure, did everybody get signed in? Did everybody get signed in on the sign-in sheet? Everybody got signed in? All right, perfect. Well, great work, everybody.
Oh,
Thank you very much.
the line. That's grandma.
Oh, and by the way, if anybody finishes this assignment early, who did not finish the last one completely, you can email me and let me know. If you finish this one before it's due, then I can unlock the previous one for you to like make up while you're still, because you finished it early, if you did it early. So I'm saying like, if anybody didn't finish the whole assignment last time and you finished this one before it's due, like 2 days before it's due, or for example, you could email me and then I could unlock the last one for those extra 2 days that you got. I don't remember exactly, but sometime, it's not, I don't think it's due on Sunday, is it? Probably on like Wednesday or Monday or something.
Next, maybe.
Probably on, yeah, it's either Monday or Wednesday, probably. I don't remember for sure.
Yeah, but I have, one that's bigger than these one next.
Well, thank you very much, everybody.